Hello students, this is Dr. Sourav sir's class. We are now solving our National Boards of Higher Mathematics PhD entrance test paper from the year 2017. So the question says what? Let A belongs to M, N, R and N is greater than equals to 2. So our A is what? Our A belongs to M, N, R. That means our A is an n cross n matrix whose entries are real. And n is what? And n is greater than 2. So our n is greater than equals to 2. So the matrix orders will be 2, 3 and all. Okay. So which of the following statements are true? First statement is if our a to the power 2n is equals to 0, then a to the power n is equals to 0. Okay, now our a to the power 2n implies 0. That means what? Yeah, our a to the power 2n equals to 0 implies what? That implies that only eigenvalue of the matrix A is 0. So characteristic polynomial of it. So that means CHA will be what? E becomes CH of A becomes our x to the power 2n as sorry, that will be x to the power n as belongs to M N R. Yeah, n M N R. So by the Cayley-Hamilton theorem, we know what our Cayley-Hamilton theorem says, that the matrix itself satisfies its characteristic equation. So as our characteristic equation be x to the power n, so by the Cayley-Hamilton theorem, we get that our a to the power n is equals to 0. So the option A is my, let me write it with the golden color, as our option A is true. Now we have to test the things about our option B. Now our option B tells what? They tells us that if our A square is identity, then A will be equals to plus I or minus I. So our B tells us if our A square is I, then AB plus or minus I. Now we can take a counter example of it. We can take the matrix, that is A is equals to my 1, 0 and 0 minus 1. Then our A square will be what? Our A square will be 1, 0, 0 minus 1. Then it is 1, 0, 0 minus 1. Then it will be 1, 1, the 1 and the 0. This position is 0, 0, 0, 0 and the minus 1 will be 0 and 1 will be 1. So this, yeah. So our A square is now identity. So, but our A is what? But our A is neither identity nor minus identity. So our option B is false. Let me write it with the golden color. Yeah. So our B A is now false. Now we have to find the logic about our option C. So option C tells us what? Option C tells us that if our a to the power 2n be I, then a to the power n be I or minus I. That means C says us if our a to the power 2n is I, then that means implies our a will be this. On the similar manner, we can take another example. Let our n be 3. Then what will happen? Then let us take a matrix that is this, and the second position 1 be minus 1. Yeah. Then we can see what? We can see that our a to the power 6 will be identity. But our a cube is not identity and not minus identity. You can calculate it. It's very easy because our a cube will be what? A cube will be the same thing as they are the diagonal matrix. No. So what will happen? Diagonal of a cube will be the diagonal terms of them will be cubed. Then 1 cube is 1 and minus 1 cube is minus 1, and this is my 1 cube is 1. So my a cube is not identity and not minus identity. So our C is also false. So our C is false. So the correct statement is if a to the power 2n equals to 0, then our a to the power n is 0. And a square is equals to identity, then a will be plus minus identity. We got counter example for this. And also if our a to the power 2n is equals to identity, then a to the power n will be equals to plus minus identity. We also get counter example for this. So the correct statement is my A and B and C are the false statements. Hope you understood. Thank you guys.